Hello everyone, welcome back to our computational thinking videos. This is the part 2 by learning aims. Remember to like, share and subscribe and turn on the notification bells. If you have any queries, you can comment in the comment section below. So let's continue where we left. We were on what is decomposition and pattern recognition. You use decomposition to break down a problem into smaller parts. As the parts are smaller, they are easier to manage. You can solve small parts of the problem and then bring these parts together to solve the whole problem. What is pattern recognition? Pattern recognition is finding similarities and differences between items. You can use pattern recognition to find the right algorithm to solve a particular problem. Imagine you are an aeronautical engineer. This means your job is to design airplanes. You want to design an airplane that flies faster. You need to decompose the problem to solve it. You might see some patterns. For example, you might look at the way the air flows over different designs of airplane wing. You need to break down the problem and recognize any patterns to find the right solution to the problem. We can also use flowcharts to show computational thinking. Imagine you have to get up for studying on a Sunday, and you and a robot, or let's say you have created this flowchart about it. A flowchart starts at the top with start and ends at the bottom with a stop, and they are denoted with a rounded rectangle, and then each decision point is represented by a diamond shape, and each process is represented by a rectangle shape. The inputs and outputs of a program are represented by a parallelogram shape. So this is a flowchart. Start, alarm rings. Are you ready to get up? When you're saying yes, then you climb out of the bed and the problem is solved. But when you're not ready to get out of bed, you hit snooze. And you see this arrowhead again coming on the alarm. What is this? This is iteration. We use loops in flowcharts to show iteration, so that we do not have to write a step so many times. So when you're hitting snooze, again the alarm rings. So you're asking again, you're making a decision again, are you ready to get up? No, hitting snooze. Then the alarm is ringing again, and the process is going to continue until you say yes and you climb out of bed, and then your flowchart stops. That is how it's going to work. What is pseudocode? Pseudocode is another way to show your computational thinking. Pseudocode is not a programming language. Pseudocode is meant for us to read, not for computers to follow. just like a flowchart, pseudocode is a way to describe algorithms, show you're planning for solving a problem, and show you're planning for a program, show how there might be more than one way to solve a problem. Unlike flowcharts, pseudocode does not use shapes to make diagrams. Pseudocode uses words. Some people prefer to show their thinking in graphical ways. For these people, flowcharts may be better. Other people prefer to show their thinking using words and sentences. For these people, pseudocode may be better. Flowcharts can also be good for working on large projects in groups because everyone can see the whole design. Pseudocode is a good way of learning to think in computational ways. Computational thinking can help us become a problem solving, focusing on problems and finding a general solution to our set of problems. What is the difference between pseudocode and an algorithm? A pseudocode is a very informal language for us to understand, not for the computers to follow. It is not a programming language. It is a natural language that constructs that are easily understood by us humans. While algorithm, on the other hand, is a set of steps which we are using to solve a problem or achieving a specific task. It is a formal language and computers can follow it, but it must be written in specific syntax and structure. Pseudocode versus flowcharts. Pseudocode is start, get 3 grades, average them, print average, average less than 80, if yes, print good, end. This is a simple kind of pseudocode with its flowchart and loop. Not exactly a loop, but both of them are coming to an end. It's showing that. You could write the flowchart information in pseudocode like this as well. Align hammer with nail. Repeat. Hit nail with hammer. If nail fully in wood, then stop. Go back to repeat. So go back to repeat in this tells us that this repeat has a loop in which hit nail with hammer if nail fully in wood are there. So that is the loop. The steps inside the loop are moved to the right compared to the rest of the pseudocode. We say that the text is indented. Indenting the text makes it easier to see which actions are inside the loop. All of the indented pseudocode shows a block of actions. A block of action means actions that are always done together. Now in this I used if. But in the next one I'm actually using while. Now both of them can be used. Align hammer with nail, while nail not fully in wood. Hit nail with hammer. Output, job done. This is more elegant way of writing an algorithm, you are doing the best for the least effort. But what if we had to make a flowchart for this? How would we go for that? We would first use our rounded rectangle box for writing start, then an arrow, then a rectangle box for showing the process. Then we're going to write step 1 is equals to align hammer with nail, then an arrow, and then step 2 in the next rectangle shape that we're going to draw. Step 2, raise hammer, and then again an arrow, then again a rectangle shape. In that we're going to write step 3, hit nail with hammer, then we're going to make an arrow, then again we're going to make a decision box, the diamond box. In that we're going to write, is the nail fully in wood? If it's going to be no, then we're going to write here, go back to step 2. And what was the step 2? It was to raise hammer. And then if it is yes, then we're going to show a parallelogram for that, and then we're going to write say job done, as it is output job done. So we're going to say job done, and then arrow, and then stop. In the next video of part 3 of computational thinking, we're going to start with exhaustive search algorithms. So if you want to see that video, remember to like, subscribe, and share this video, and turn on the notification bell so that you can be notified every time we post another video. Goodbye for now. Have a great day ahead.